each
Yeah.
street.
If he was short, he was like 5'9".
That's okay.
I've been hiding inside all day, so I didn't know that.
I know.
I knew the weather.
I know. I know that I'm just like there and I'm tired. I didn't want to leave, you know. And then this guy. That's what I would never do that. Like, I would be like, I would feel so insecure. Like, we are going now that we come out next weekend. I'm really excited because when we were going to come, and then I'm like ignoring him. We'd be like, and then I'm like, yeah, like, has to be like,
Building intro.
yeah, yes.
Units.
Like, I'm actually so excited to go and do that. Honestly,
It's just your easier master.
yeah. Yeah. Wait, that's a good idea. He was like, oh, he was like, I thought you were actually on that.
What's your first master?
Yeah. I was yeah, that's what they said.
Some of my mom. It's just because we brought health science, we can do the reading and questions. I did most of the time. I think I did. But that's what it is. Yeah. I have my. Maybe not.
Alrighty then, happy Tuesday afternoon after a little bit of a break early in the semester, but we needed that one anyway. This is part 2 of Deluges and Drought. Today we're going to take some of the numbers that you researched the other day. We're going to put them to good use. We're going to talk about the hydrological balance of Lake Huron both today and yesterday, or 8,000 years ago. Then we're going to do a little experiment, what they call a sensitivity analysis, and we're going to try to determine why, or we're going to make some guesses, or we're going to make some calculations to support the concept of why it was drier. And in the end, the answer can be less rainfall, which is always what you'd think to make a lake lower, but evaporation's in there too. So I'll walk you through that. We'll get through the calculations. That's our objective today. We will stand back in the bigger picture on Thursday, and I'll talk about the significance of deluges and droughts, the hydrological balance, and we'll go from there. Before I get going any further, questions from you folks?
So for the homework assignment, I found a website that gave me that information, and you said the values were too low. Where would be the best website?
I'll explain that. There was a lot of people had the same error. The conversion was a little guffed up, or something that probably wasn't obvious. But I'm going to explain that.
Okay.
Second point is, Liz is AWOL on me right now, so there's not the assignment's usually posted before we start, but there is a PDF of this lecture on the files page if you're following through, so you can find it there. It will take me a couple hours this evening before I can get the assignment posted up formally, because I have another class and then a meeting directly after that, so just to bear with me a little bit on that. Any other questions? All right, let's delve into it. The first thing is, why do we do this exercise? Numbers. Numbers are about, in some senses, are about, not about science, but numbers are a tool to express concepts. It's okay to say that it got drier, but how much drier? It's better to put some sort of number on it. So we want to put some numbers to this concept here. And then what I'm going to sneak in on you is we've got two things that could explain our observations. And which is it? And the answer, it's both of them in some combination, but we'd like to know which one may be more important. And so I'm going to set up the problem. The challenge that we had of today getting some units was to get into the meters cubed per year. And they fell into two categories. One was a category where basically very few of your answers were meters per year, and that's fine, that was noted. The second was what this gentleman just asked here. The numbers are too low, and I've got a graphic for that, but on the next slide. I want to outline for today, then after we get through all that, we're going to balance the equation. That's where we'll spend most of the time, and I'm going to tie it back to climate in some sense. But let's get that unit conversion taken care of first. First of all, remind us the concept of flux, and that's some unit per time. The unit that we were picking for this exercise is metered cubes, and that's that big thing like this of water. Okay? We asked for the question in meters cubed per year because we want to get we're going to make up an algebraic equation, and they have to be the same units. It's not going to do any good to take 100,000 cubic things and then subtract a different unit. We need them all in one unit. I just picked this one because that's the one I used before. It's not the only one necessarily. When you did that, one of the things that might have glitched some people is that you have to convert time to a year. And so there's so many thousands, hundreds of millions, whatever seconds it is per year, and that would be interesting. The precipitation evaporation flux was the one that got most of us. The number you probably got was something like 30, 40, 50 millimeters, right? Okay, 30, 40, 50 milliliters of what? Because millimeters is one dimension. we want to convert, we're talking about something that's a cube, that's 3 dimensions. So we have to take something that's in 1 dimension and somehow convert it to 3 dimensions. And that's where a lot of zeros get lost. 1 millimeter refers to something, 1 or 30, whatever number you got, covers an imperial surface to a depth of 1 millimeter. So if I had a millimeter of water on here, it'd be 1 millimeter of the whole thing. Is that the volume of the water? No, that's not the amount of water. If I took this water and poured it off into a gallon jug, how much I would have? It's not a millimeter, right? It's a millimeter times the area. And so that area becomes important. And that's why one of the numbers that looked up the area of Lake Huron. It's because that's a number that you need to convert those evaporation and precipitation values to some flux. Does that make sense?
Yeah.
And it's really easy for me to tell you. One of them has about that many zeros, and the other one has that many zeros, the decimal point in that many zeros. So the real thing is, if you converted the millimeters to meters, that's a small number, but then you take the area of 56,000 whatever square kilometers of Lake Huron, that gets a big number. Any question on that? There's also the role of temperature in hydrological balance. This is an interesting topic because temperature and hydrology, or temperature is what we always think about global warming. I'm making a case here that hydrology could be as important, if not more so. All you have to do is watch the floods and droughts, and you can see that. But does the temperature matter for the hydrological balance, or are they separate properties? Of course, they're not separate properties. Nothing's that simple in the climate system. And so we would thrash around with that. And I made a suggestion that you do the conversions on an online source. I've never done that in the past, and we've always ended up with a whole range of values, and we're a lot closer to uniform values today. I may, in fact, I think the values that I got are not necessarily the only numbers. There's a range of numbers that you might have gotten. And if you get a 15 out of for that points, then you can use those numbers. I'll probably publish the other numbers, but encourage people to be comfortable with the conversion before that. Anything else on that? All right. These are the resources you could have used or might use or whatever. The thing that I look for is it's an EPA site, it's a Michigan or site. Wikipedia is not a whole lot of use in this. Something University of Michigan, the Great Lakes Society, there are many others. The general notion is that the Great Lakes are these multiple big lakes. And Lake Huron is one of them. Water drains from Superior and Michigan into it. I had screwed up in the original description, so I'm not too concerned whether you got both of those together or what. It's a little crazy, so that numbers may not have been the best. But all these yellow and green balances here are the precipitation evaporation, the two other terms, and then something about runoff. Runoff is that amount of area that's outside of the lake, but precipitation can still fall on. And we're kind of sneakily going to avoid that a little bit here. But the point is, all of these things have a hydrological balance. All of them have some complexity. There's a river that goes out through Chicago to take some water off there. The rest of the details aren't necessarily important to us, but to understand that we're just looking at one little piece of it for simplicity's sake. Let's see. I'm going to hammer this flux again, rate per time. Rates per some value of time. Fluxes are very important in most of the climate scientists because they talk about the energy. It's one thing to have a lot of energy, it's another to move a lot of the energy. So when we put time on it, it's something about moving. in this particular example, it's about moving water. Now, we can move a little bit of water by evaporating it every second for the course of the year, or we could deluge it. So in other words, I could flip the coin. If I want to accumulate water, do I want a little drizzle over a big area or a bucket over a short area? The fluxes could be very different geologically, but they may have the same amount of water. It's just that one came in a big, one fell swoop, one came in over time. And as long as you get the fluxes in any problem straight, they come out. A lot of hydrology is in the factor of Q, because it's discharge, because the rivers talk about discharge, and Q is the classic number for that, and that would be in meters per cube per second, not per year. All right. Now the last question asks you to compare the two examples that I had, and I kind of made a point, and I don't know if I was how explicit I was about it. I don't remember. But they basically both happened about the same time. Not exactly, we could nitpick about it. But we talked about, first of all, the Sahara being dry, but not 8,000 years ago. It was wet, there were lakes all over the place. And then we talked about the Lake Huron, specifically, in the sense that it, 8,000 years ago, was much reduced. In fact, there was no rivers going into it or coming out of it. Little streams maybe, but no rivers. And so I ask you to contemplate that question. So part of that is, you'll see this, I've already hinted, you'll see this question again. It's more of a interpretation, what does it all mean, significance. What it really means is you can't change a major part of the hydrological cycle without changing some other part of it. Here's this is this morning's value of how much water is in the atmosphere today only. And that's potential rainfall. That's not necessarily going to rain. That's just the amount where the water is. And so the water is spread over a big band north of the equator here, which is fine. It's also spread around quite a bit in the Atlantic and has to do with the storms and whatnot in the Caribbean. It's dry as a bone up here. That's why there's forest fires still. It's dry in most of South America, at least the windward side. It's not actually as moist. All of that swirly storms that we see down around the Atlantic are fairly dry right now. But the other value, so how do we get more moisture here or less moisture there? That's one model, simply changing how much rainfall we get. But the equation says it's two components, precipitation and evaporation. Could we do the same trick with evaporation? We'll delve into it further, but these are basically tied to atmospheric circulation patterns. And if you're monkeying around with it someplace, it monkeys around with you someplace else. That's a big take home. Okay, that's why I picked these two examples of drought and deluge. Several of you pointed out that places like California we were hearing nothing but the drought, and then all of a sudden we heard about the excess precipitation they got because of a hurricane. Those are very short time scales. Those are sort of the things that vary year to year. Changing those things took sort of, for our purposes, a millennium. So for 1,000 years, they were in those conditions, in round numbers. We can fight a few hundred years on them. So those are a more fundamental change of state than a hurricane or whatever. What was it? The Burning Man got drowned out this weekend because of the flooding, the rainstorm. It's a dry lake bed. It's a lake bed. It wasn't a lake bed. Do you think that there's a chance that sometime hydrologically it could have been a lake? Yes. So sometime it's going to rain, there's going to be precipitation there. They were lucky they only got a few inches or whatever it was to make mud. If they drowned, it had a few feet, they could have drowned. Okay, harping on this theme of long-term versus short-term. some of the things that you would find, the precipitation values in millimeters, and that would be precipitation value per year. So that wouldn't be, you know, this is 3 meter, this is a number here, and here's a time series, what we call the age, and it goes back to 1950, so we've got roughly 50, 70 years of record there. And we see that no 2 years are probably the same. You probably could find some year that there's a couple that are awful close, but we have a value, and that value actually has some trend to it. So there's something going on a little bit, but it's not a flat line, and most recently it's been going up for Lake Michigan and Huron, but not every year. The evaporation is more variable. Slightly less value in absolute numbers, but it's got more variability in the sense of it. If you put those two together, if you just talk about this at the simplest sense, how much water is actually running off? Well, because it's raining more than it's evaporating, there's got to be something running off. Now we're going to flip that switch because we've got a time when there was no rivers running out of the lake. So we need to get a slightly different balance. But these give you some sense of how much is, and these aren't perfect for our analog because these are also including